So I've just gotten the 2 thumbs up from Rory to begin. We may have some other folks joining us as the presentation continues. But let me introduce myself. My name is Zapata Courage. I'm a district wetland ecologist with the State of Vermont Wetlands Program. And Rory invited me both last year and this year to talk a bit about what a wetland is, when you're working the land, what kind of clues the soils specifically can give you about whether or not you might have a wetland in the area that you're farming or proposing a project, the types of agricultural projects that you might be involved within, and whether or not they might need wetland permitting. So with that, feel free to, for housekeeping, I've asked everyone to put themselves on mute as you've joined so we don't have accidental interruption. Also, if you have any questions, if you could please put those into the chat, and the chat option is located at the top of your screen, that little speech bubble. In addition, you could also raise your hand, also found at the top of your screen. And Rory will be monitoring both the chat and the raising of hands to let me know. I'm happy to address questions as they come, but also recognize that I might anticipate your questions and be answering them throughout the presentation. If you are here in person, we have some wonderful handouts that could have gone home with you, as well as some refreshments. So keep that in the back of your brain for next year. All right, here we go. I am going to start from the beginning. And I have to, I'm going to do this. And because we had the audio issue, I just need to remind my computer that I'm actually doing a slideshow. All right. Okay. So first of all, to make sure that we're all on the same page about what a wetland definition is, both for the state of Vermont, but also for the Army Corps of Engineers. And it's those areas of the state or those areas on your land that are inundated by surface or groundwater long enough to support significant vegetation or aquatic life that requires those saturated or seasonally saturated soil conditions in addition to appropriate vegetation. And so really what it comes down is to 3 parameters. And these are the 3 parameters that also inform a delineation where we identify the boundary of a wetland. And so we're looking for 3 things. First, we need to have the presence of water. And where is that water coming from? Where is it going? But more importantly, how long is it staying in a given place? Once you have water and it's there long enough, then we want to be looking at the soils. So if we think that there's water, then we're going to be looking at the soils. When you have the presence of water, it pushes oxygen out of the soil. And instead of a warm brown color of the soil, teddy bear brown, or just plain gray, we end up getting a mixture of colors. We end up what looks like rust. We end up with your cool brown colors such as blue brown, gray brown, black brown, even green brown. Once you have water and it's there long enough to change your soils from being upland to being wetland, then we're looking at the plant community. All of your plants are rated based on how often they're found in wetland. And when we have a dominance of wetland-loving plants or prefer to have their roots wet, then having those 3 parameters in one location, that is where your wetland is located. Then we start working out until at least one of those parameters no longer exists. So getting into some of the specifics, what do I mean by wetland hydrology? Well, wetlands are formed from the presence of water, and they need to be flooded and saturated long enough to create those special conditions to change your soils and to promote the growth of water-loving plants. And so Evidence of wetland hydrology can be obvious, like I'm walking across the ground and my feet are getting wet. I dig a hole and it fills up with water. When it rains, where does the water always drain? The drainage patterns. If I'm thinking like water, where on the earth would I expect water to concentrate? Think of water running downhill, water collects at the toe of slope. The important part here is that you need to have inundation or saturation within the soil surface, so the top 12 inches, for at least 5% of the growing season in most years. Growing season, for the most part, and especially in Addison County, Champlain Valley, is typically from April 15th to October 15th, plus or minus a couple of weeks, depending on the weather conditions. And to have soil saturation for 5% of that growing season equates to approximately 2 consecutive weeks. So it doesn't actually take too long, but those conditions need to be persistent and consistent. So wetlands are also often associated with streams or lakes because the hydrology is already present in the form of surface water. Then it's just a matter of, is it there long enough to form those other 3 parameters? So for hydrology, primary indicators, like I mentioned before, could be things like surface water, or looking at this black and white imagery, being able to see where inundation is occurring, saturation is occurring. The high groundwater table, that's what your septic designers are often looking for. How far down can you start digging before you find evidence of that seasonal high groundwater table? And mentioning the presence of the rust, there's actually a scientific term, it's oxidized root channels. You can also smell hydrogen sulfide. And so you can also have secondary indicator examples, and I think if you look around, you'll start to see these. Where are your stunted or stressed plants? Which areas of your field always struggle to grow corn or your soybeans? What areas of the fields do you wait until the second cut of hay before you get in because the ground is a little too soggy? Again, those drainage patterns are your geomorphic position. So once we've established that you do actually have water on the landscape, then we're asking whether it's there long enough to change your upland soil to that wetland soil. So in Vermont, we typically have 2 types of soil. They're either mineral soils or the organic soils like peat bogs. Your mineral soils, when introduced to water, and can you actually see me in the little screen, like my hands? Okay, so when you have soil, you normally have oxygen between all of your soil particles. And we have a lot of iron in our soil in Vermont. So consequently, the soil, when it has lots of oxygen, no water, then that's when we see our warm brown colors, the red, orange, yellow, brown, teddy bear brown, boring brown. You dig a hole and the top 12 inches, 24 inches is basically all the same color. When you have water, the water starts coming in and fills those pores and pushes oxygen out of your soil profile. Now decomposition is happening in the absence of oxygen. And that's why we see a color change. Instead of those warm brown colors, we go to those cool brown colors. And we can also see evidence of concentrated rust. And that's what's happening is iron becomes soluble in the water is moving it around, and it starts creating different colors within your soil, starts concentrating rust, or along our root channels, you will actually see a line of rust, and that's called oxidized rhizospheres on living roots. And it's no different than if I go up to your brand new car and I key it, I am now exposing the metal underneath your paint. The paint is keeping out the oxygen. As soon as you remove that paint, it's exposed to oxygen and it rusts. All plants take in carbon dioxide. they breathe out oxygen, and they do that through all parts of their structure, including their roots. And that's why we can sometimes see rust actually form around those root channels. In addition, sometimes we see like little black flakes, and that's manganese. So first, do we have water? Is it there long enough to change our soils? For those of you that are familiar with the ANR Atlas mapping or the wetland inventory mapping, on the left-hand side of your screen, that's what the mapping looks like. You can turn on and off the soils layer, and the hydric soil, all the soils are labeled by a 2 or 3 letter combination. You can click on it and find out what it is. Those soil polygons, if you will, can be pretty informative, and they were created by NRCS USDA really to inform the farming community of how good these types of soils would be for different types of crops. That has since evolved to also recognize where a higher likelihood of wetland formation might occur, because as soils are deemed poorly drained, they are called hydric soils, which means they may hold water longer than other soils and form those wetland conditions. There also can be very informative for septic design. Once we have water, changes our soils, then we're looking at our plant community. So when you look around the landscape, what is a wetland plant? A wetland plant means that they are, quote, water loving. In reality, they're not. They have just adapted to growing in low oxygenated conditions due to the presence of water. And consequently, they vary in their tolerance. So a cactus hates to have its feet wet. Cattail loves to have its feet wet. 99% of the time you see a cattail, you're likely to be having a wetland, unless it's in a ditch or a pond. 99% of the time you see a sugar maple, you have upland. Red maple, 50-50. White paper birch, upland. Yellow birch, 50-50. And so here's just a couple of pictures of some of the wetland plants you might be familiar with. Reed canary grass, which a lot of us have planted on our hay fields because it's great, a hay foraging material. They can really tolerate those wet conditions. So if you go down along the Otter Creek, and all of the hay fields along Otter Creek, they're dominated by reed canary grass, as opposed to timothy grass. Timothy grass is an upland plant, but foxtail is 50-50. All of your dogwoods are considered wetland shrubs. And if you see the sensitive fern, which is down in the down at the bottom middle screen, it looks very cartoonish, kindergartenish. That can indicate potential wetland. It's also a 50-50 plant. So your plants can tell you a lot about what's going on with the moisture regime on your land. And when you have a dominance of water-loving plants, then you have met that plant criteria for wetland identification, coming back to those 3 parameters I mentioned before. So in Vermont, what is a jurisdictional wetland? Our legislation was passed to protect wetlands based on their significant functions and values, and consequently they are regulated by and under the Vermont wetland rules by the Vermont Wetland Program. And I would be your contact for both Addison and Rutland County. Not only does Vermont protect regulated wetlands, but also their buffers. And I'll talk about that in just a moment. So to give a little history to understand where we came from and where we are, the first wetland rules were adopted in 1990. That's an important piece when it comes to agriculture. Were those fields, was your barnyard, was your pasturing area already established prior to 1990? Because in 1990, the Class 2 wetlands were those that were mapped or connected to mapped areas. And that changed in 2010 because we realized our mapping was terrible and it's not accurate. It gives us good information to say, hey, we think there could be a wetland here. And generally speaking, that's not bad information. But the mapping does not at all show us where the actual size, configuration, the wiggle of the boundary might be. And so we protect activities that are proposed within wetlands or their buffer zones. And the buffer zones extend for most wetlands to 50 feet. And so permits are issued when an activity cannot occur elsewhere and the functions and values are not going to be adversely affected, or if they are, that they can be mitigated for. So these were the 10 functions and values the state identified as being worthy of protection. So, the flood storage, for those of you that farm here in Addison County, you certainly know about, Irene and the Otter Creek wetlands and the water quality pieces that you guys have been working really hard on. That's one of the reasons you're taking this presentation today. All of the habitat for fish and wildlife, for rare, threatened, or endangered species, erosion control around our streams. We see that, with farmland as well. Having a woody vegetation along your banks help keep your land in place as the rivers try to move. And then also for things like recreation, education, and research, and even open space, which becomes more important in our developed areas. So this is just the one example because it became pretty well known and it became well researched, and the wetlands between Rutland and Middlebury, distance of approximately 35 miles, basically became another Great Lake when Irene came through and filled it up. Consequently, they were monitoring the river gauges, in Rutland and in Brandon, and the amount of water that was coming through was just off the charts. And then they were reading the river gauges in Middlebury, and the amount of water coming through had dropped to such a level different than Rutland and Brandon that they thought the river gauge was broken. And in reality, what happened is what you see here in this LiDAR image is that the wetlands, that the waters just spilled into those adjacent wetlands and never reached Middlebury. And here is a photo of the Pomainville WMA as you're heading out of Brandon and into Pittsford. And you can just see the tops of the trees, and Otter Creek would be in the background up against the mountains there. Oh, and this is, I think this is leased by maybe the Knops. This is the farm fields right against the Leicester River, where across the street on Route 7 is where the osprey nests are. So those of you that are familiar with the areas, once again, these fields take on the floodwaters and hold them, and so that these waters never make it down and through Middlebury at the crest of the floods because it holds it back. And that's a reality that's happening. And so I'm putting this chart up because I'm hearing certainly much more anecdotally, well, there never used to be a wetland here. Or in the case of that previous image, this field, we used to be able to get 2 cuts of hay off of it. I'm lucky if I can get 1 anymore. I can't get in there on the spring. Now that we're getting the floods that seem to be happening in July, I have to really time it right or we don't get anything. Those are all true. And they are real observations. What we're seeing and what has been tracked by NRCS, since the 1900s, but more importantly, since 1970, the Northeast area, New England, is experiencing between 5 to 9 inches more precipitation per year than we used to. And so what that means is that our groundwater tables are also rising. We are seeing more extreme events with a greater level of rainfall in a shorter amount of time. And it's keeping our lands a little bit wetter, and it is increasing our potential for flooding. So when we look at aerials like this, you know, where there's already a lot of water and a lot of inundation and saturation, if we continue to rise up the groundwater table, or the rivers continue to flood into the adjacent areas and behind those natural berms and can't drain back in, then what we're seeing is that these wetlands are getting bigger and bigger over time. So here's just a quick overall overview of desktop reviews, some mapping tools that are available to you, and some in-field observations that could be helpful. You know, do I potentially have a wetland? So if you are familiar with the ANR Atlas, then you can open it up and you can turn on these specific layers. So the ANR Atlas allows you to turn on and off layers based on what you want to see. For wetland specific information, these are the layers you would want to turn on. But if you wanted to know if you are in a floodplain, you could turn on and off that layer. If you wanted to know that if you were working in a river corridor, you could turn on or off that layer. So these are for the wetlands, or you can go to in ANR Atlas, where it says Atlas layers, you could select just the wetland layer and it will automatically select all of these for you. You can also go to the Wetland Inventory Atlas, separate from the ANR Atlas, and once again, once it loads, all of these layers are already turned on. And each one gives you some information. So if you see a green star on the map, that means that there has already been some type of review in or around that area. Not that there was a permit issued, just that there was some type of review. And I may have some information for you on that. And in the meantime, a lot has been, and I know this is a conversation that's happening, a lot has been happening with our maps. We've been updating them now since 2023. Way up top, the Missisquoi Bay with the yellow star was the first to be updated. And it was an area of approximately 603 miles. Since then, the area which we are in, outlined in red, was completed last summer. And those updated maps have been added to the ANR Atlas and the Wetland Inventory Atlas. The Connecticut River Basin was just finished this past spring. And that includes everything here outlined in dark green. So basically the entire eastern side of the state. And currently, and about to be finalized, what is the remainder of the state, which is primarily the southwestern area and then the Lamoille River Basin up near Missisquoi. And so our area specifically is River Basin 8 and Basin 3, and that includes the Otter Creek, Little Otter Creek, the Lewis Creek, the Pike River Basin, in total 107 towns. And this is kind of what the statistics were. Recognizing that as we are updating our maps, not only are we adding wetlands to the map, and let me be clear, we're not just randomly deciding to add a polygon to say, oh, there's a wetland over here. That wetland has always been on the land, but with new mapping techniques and tools such as color infrared, the use of LiDAR, black and white imagery, higher resolution, we're actually able to identify where wetlands are on the landscape better than we have been able to do before. So when there's been an area previously not mapped, but we're able to see that there's wetland there, that is where the added wetland comes in. We're adding that polygon to say we have a high confidence that there's wetland here. We also can still be wrong, and we're okay with that. And you can let us know when we can come out and do site visits with you. In addition, we are removing old mapping where we know there is no wetland present. The polygon was put over somebody's house. It's on the top of a mountain. They circled the pond or the manure pit. We're trying and have been trying to remove those over time as well. And so this just tells you the number of acreage in the watershed that was evaluated, the quality control and assessment that we did by doing field checks and trying to calibrate what old mapping was versus what new mapping was, and then where those differences occurred. Did we add, and what did we remove, etc. And so what does that actually mean for you? How does this new mapping affect farmland? In short, it doesn't. Because since 2010, any wetland, mapped or unmapped, that is a half acre in size, or is associated with a water body, or is a vernal pool, or is high elevation, which isn't where you're at, are class 2 wetlands. So whether they were mapped or not mapped, you are potentially always subject to regulation. We'll get into some of the farming pieces because there's a lot of exemption around farming activity specifically. But this new mapping doesn't change our level of jurisdiction. And so here are two images. The top left-hand corner was the old mapping, and the old mapping is shown in red. And what I did is, if you follow the images through, I kept the plain field orange boundary at the same place. And you have the barns right in kind of the middle of each of the screens. So the old mapping was pretty pitiful, and it missed a lot. And the new mapping is what is in teal. The reality is even the teal, based on doing just a desktop review, is probably still under mapping what is there. I'm guessing that there's additional wetlands that could be along the stream on the eastern side of the property. A field visit would verify that. So the new mapping does not increase our regulatory area. It just provides you with better information on where wetlands might actually be on your land. And so this also ties into your hydric soils. So hydric soils are the polygons through NRCS and USDA. The wetland program did not put together the hydric soils. We do not manage the hydric soils, and we do not update the hydric soils. Just as any polygon, these are old polygons. They were meant to be relatively crude, but slightly informative of, to inform good farming, types of soils. But these polygons are not accurate. They're blobs. Hydric soils mean that they're poorly drained, but poorly drained does not automatically mean that they're wetland. A hydric soil in and of itself has no regulatory status, not for the wetland program. But if you do have hydric soils and you are planning a proposed project, then an in-field observation, a site visit, might be needed to confirm the presence or absence of a wetland there. So here's a good example. It's 3 images, but first I'm going to draw your attention to the right-hand side. And we've got the road kind of running up the middle of the screen. And immediately next to the road, there's a splash of light green. Then you have the dark green kind of almost oval. And then it changes color again, moving further to the east, kind of splotchy green, brown, and then it even gets even more brown. If you drop yourself on street view and start looking across, you can actually, when it's mowed, you can kind of see that there's an elevation change. But when it's not mowed in that bottom, you can start looking across, you see the tops of the grass, and all of a sudden the land rises. Where that land rises is where that dark green oval is. And when I turn it on in the wetland inventory atlas, this is what we see. So the green star is on that dark green oval where the ground is rising in elevation. The pink is your hydric soils, and it totally corresponds almost to that lighter green going into the splotchy brown green. And then the khaki, I don't know, pea green, lime green, and turquoise, those were the wetland inventory mapping. Again, crude polygons meant to be informative, have a pretty high confidence. This area is wetland. And the soils in that wetland are mucks and peats. And this landowner wanted to do a project, and so they got a delineation. This is what the delineation looked like. And so when you look across from an aerial desktop review from the left to the wetland inventory atlas in the middle to what was found on the ground doing an actual delineation, you can see that while each one doesn't completely overlap the other, it was pretty informative as to where the wetlands were most likely to be with that 50-foot buffer. And that's a puzzle piece to then say, okay, now I know where I can put my new barn. I know where I can put my new manure pit. I know where I can dig that irrigation pond. And so in my last presentation, Rory asked if I would talk a little bit more in depth about soils, because that is what you folks are tending to work with so much. And so to give some basics, we have a groundwater table beneath our feet, and depending on where that ground table is, how far below our feet will dictate whether the area above it, the soil that we're standing on, is going to be saturated or inundated. And so that's what the top photo is looking at, is that while the groundwater table is level across the landscape, as the land starts to rise and becomes further and further away from that groundwater table, you're going to have wetland where it's less thick or less deep, and then you're going to move to upland where the land has continued to gain in elevation and further away from your groundwater table. That's not always true. We can also have what's called a perched groundwater table. And we do see this in Addison County, which is why I wanted to bring it up. I especially see it in Ferrisburgh, Panton, Addison. Those are the three main ones, Weybridge and Weybridge. And we have what's called sand over clay, clay plain forests. And literally, it is a layer of sand on top of clay. Depending on where that clay layer is, how deep below the sand or how deep below our feet will dictate where the water that collects on top of it will be located. Because clay, that's why we make our pottery out of clay. It does not drain water, it holds water. And so clay can act, and bedrock also can act like a perched water table. The water cannot keep going down. It sits there and saturates the ground above it, and or it starts to move horizontally. So some of you closer to Otter Creek may see this. We certainly saw it in Weybridge. Quaker Village Road sloughed off into the Otter Creek because of this phenomenon. The water came down, went through the sand, hit the clay layer, started moving horizontally towards Otter Creek, and as it hit the bank of Otter Creek, it completely destabilized it, and all of the material above that clay fell in, which also included the road/driveway. So you can see that happening also potentially on your land as well. And the capillary action, this is really based on what type of soils you have on your land. If you ever pour water onto your counter and take a paper towel and dip it in, and the water runs up the paper towel, that's capillary action. The soils do the same thing. And depending on your soil composition, is it primarily made up of sand? Is it clay? Is it loam? What percentages will dictate what that capillary action is. How far up will your water table migrate because of that force? And so we all start with parent material, and we have the two categories of soils in Vermont: your minerals, which are their sands, your silts, and your clays, versus your organics. In Addison County, we don't tend to see a whole lot of organics until we start getting up into higher elevations, and that's due to colder temperatures and slower decomposition. So higher elevations, we're going to start to see the accumulation of peat, mucky peat, and just plain old mucks. You can get pockets of that in the lower, I'll say the valley, but for the most part, you're dealing with sand, silt, and clay, your mineral materials. And this is how soils are formed. And this is also why you have a nutrient management plan. This is why we talk about soil health, is because all of these factors go into the creation of your soil, and they're interrelated factors. You're starting with your parent material, and then what is your topography? How is your climate conditions impacting, breaking down, building up your soils? What type of organisms? That's the big thing you folks are working with. What organisms are on the land, using the land, within the soil itself? What type of plants are on the land, taking up nutrients, giving back nutrients, providing shade, and then time. And time is the big one. And every time we work in our compost pile, we're basically introducing all of these factors, and we're getting the clock going a little bit faster than geologic time to create good soil. And so everything that we see factors into the making of our soils. And a soil order is the highest, most general category in USDA. And basically it's no different than plants or birds, right? We group them based on their similar dominant characteristics. And that's the same thing with our soils. And so based on the climate, parent material, vegetation, weathering, USDA NRCS came up with these 12 soil orders. And they represent broad differences in the soil development, and they all end in the word SOL, which means that there is the ability to break it down further. This is just your broad definition. And so in Addison County, I blew it up so you can go to the soil maps, and they're actually quite a lot of fun, and they provide really good information if you like reading big words and trying to figure out what they all mean. But I blew up Addison County, and the majority of Addison County are your amphisols, with some of your histosols and inceptisols thrown in just for fun. And then of course you have your water bodies. Those are the light blue, so don't get confused about that. So once we have our soils and we kind of understand what we're looking at, then we're also looking at how they are put together and layered. What are their horizons? And so your very top layer, if you're not scraping it off and not mixing it in, then your top layer is usually your O layer or your organic layer. Then you would have your typical surface mineral layer that then gets further broken down and becomes your subsoil. Your sea horizon is your underlying material, or think parent material, followed by bedrock. Once we dig down far enough, we are going to hit rock at some point. And so when we're looking at them, oftentimes there'll be reference to what's your layer 1, 2, 3, and 4. What are your horizons? Horizon 1, 2, 3, or 4. Oh, that's my O horizon. That's my A horizon. And looking at it in an actual soil profile, you can see. And what we're really looking for is where we're seeing distinct changes of composition and color and texture. And so here you can see we have the organic layer, which is where all of your grass and little roots are way at the top, followed by your A horizon, that nice, deep brown, happy soil, followed by your B horizon. So starting to lose some of that color and nutrients, dropping down into your C horizon. And I am not a soil scientist, so if you have specific questions about soils and some of the technicalities of soils, that's where UVM Extension and some of your other folks in NRCS and USDA can assist you. And this just corresponds to labeling. And so as I mentioned, where does my color come from? And it's the oxidization, so oxygen, and reduction cycles as it relates to soil color. And so in the subsoil horizons, B and C, that's where our iron and our manganese are giving the color, the soils, their characteristic, those browns, reds, and yellows, when you have enough oxygen to brighten them and present them to you. Now, when your soils are saturated, and so my image below, basically all of your soil particles are coated with iron oxide. And when oxygen's there, it's able to present itself as red and orange and yellow and happy. When you remove the oxygen and you saturate it and you start to produce a reducing environment, then the iron and manganese becomes mobile, i.e. you're removing them from their soil particles, get stripped away, and consequently you're left with your gray or your cool brown colors of your soil. And then we start to look for other characteristics for why it is or is not a wetland soil. So if you're digging things up and you're starting to see masses or rust along your pore linings or nodules, hard concretions of black, which is manganese, then you should really be pausing and saying, I might have a wetland here. What activity am I doing? Do I need or do I not need a permit? So this is sort of, soil 101. What is a mass? It's a soft body. You can find it in the soil matrix, which is the main part of your soil. It can be variable in shape, whereas your nodules or your concretions, concrete, hard to the touch, like a pebble, can be irregular in shape. It can have a diffuse boundary. Sometimes it'll even have a halo or a corona around it, almost like a glowing orb. And this is what I mean about rust along the roots, the pores of roots, where the oxygen from the root is bleeding out around it, and consequently we're seeing that rust formation. And this is what it looks like in a real soil when you break it apart. I think that's even my hand. That's a good picture. So this is what we call a depleted matrix. And as long as this starts within the 10 inches of the soil surface, then you're likely meeting that parameter for a wetland soil. So here are some challenges. Sometimes it's really hard to determine if an area is wetland or if an area has a hydric soil or what the dominant plant of that area is because of the land use, whether that's for agriculture or silviculture. You could be missing one or more of those parameters. It's no longer naturally vegetated. You've been mixing the soils. Perhaps you've been applying manure application, which also can make the, so plowing can introduce oxygen throughout. Manure application can create darker soils than what would normally be occurring there. You could inevitably actually be creating an artificial restrictive layer, kind of like that clay layer I mentioned before. That's your plow layer, where you have now made a hard pan just, a foot, 18 inches below the surface of your field, that now is holding water where otherwise it would not. Obviously, hydrologic manipulation, ditches is a big one. And then soil compaction. If you start looking to where all of the wetland plants are growing, it's always where your tractors are coming into your fields. Why? Because that's where the soil is the most compacted and the water can't go anywhere. It just sits there. So is farming exempt from the wetland rules? The answer is yes and no. And just about any question you ask me, the answer will be yes, but no, maybe, and it depends. And that's because often it is site-specific, wetland-specific, and activity-specific. And we're also looking back to that 1990 date. What is an allowed use or an exempted use versus what is not? Is it something that's ongoing? Is it something that's new? So typically your fields, if you are growing food or crop, which can include fiber, Christmas trees, maple sap, orchards, growing of food and crops as far as raising, feeding, or managing your livestock, poultry, horses, even fish farms or bees for profit. Keyword is profit. Take that with a grain of salt. And so if you have a field that has been in ordinary rotation since 1990, you can continue that activity without a permit. You can change its crop. You can go from corn to hay. You can go to hay to soybeans. And you can say, I'm done with using this as a crop growing field. I'm going to just turn my heifers or my horses out into this and make this field a pasture. Any and all of those are exempted uses if that field has been a field since 1990. If you're proposing a new farming activity that's going to be within wetlands or its 50-foot buffer, it's going to likely require a wetland permit. And if you had a field that has now been abandoned for more than 5 years or has grown up into a dominance of woody vegetation that would require its removal to be able to put it back into production, i.e. reconversion, you will most likely need to get a wetland permit. That's also true for Army Corps of Engineers. And if you're involved with NRCS, then you really also need to look very closely at your labeling of your fields and what activities are allowed or not allowed based on that labeling for you to continue with your NRCS eligibility. So if you need to clear woody vegetation to create pasture or field, i.e. conversion, you'll need a permit. If you're going to have any new infrastructure, you want to put in an access road, agricultural buildings, you need additional waste storage, you want to put in new ditches or ponds, need a permit. Tile drains, that is a gray area. That you want to contact me for because there's a lot of nuances to tile drains. The one thing I can say for certain is we need to know where your outfalls are going to go. If your outfalls are going to be within wetland or within the buffer of a vegetated wetland, then you will need a permit for those outfalls. And we have a different permit available for that as part of a water quality. So again, get in touch with me and I can walk you through that. And there's specific NRCS designs that can be employed. And if you're going to be doing any type of berming or river stabilization, i.e. ripraps. So first of all, if you're doing berming and you're building up material, it may not only be jurisdictional to me, but it may be issues with the town floodplain regulations, and it may be an issue with the rivers program for stream alteration. If you're doing river stabilization, like putting riprap along a bank, again, it might be jurisdictional for the wetland program. So me, but it also may require Army Corps approval, and it may require a stream alteration permit. So when you start to get in and around streams, you really want to make sure that you have everybody involved who can give you the sign off for that project. So here's the example. This is, just a quick hand sketch, but your square is the fence to your pasture. It has been pasture since 1989, so prior to 1990. There is wetland occurring within that pasture, but because it has been an ordinary rotation, it is considered exempt. You can continue to pasture it. You can till it under and make it into corn or hay or other crop without a wetland permit. In the meantime, right outside the fence, the wetland continues, and it's actually a forested wetland. That wetland has not been in ordinary rotation growing food or crop. Therefore, it is jurisdictional, and it does have a 50-foot buffer, which could extend into your pasture. So what does that look like from a project standpoint? That if you were going to be building a new pond and you're going to be wanting to build that new pond in the wetland, then that pond is no longer growing food or crop. You'll need a permit for that pond. And then we would say, well, why can't you move the pond out of the wetland? And then you don't need to have a permit. If you say, oh no, I just want to put in a new access road, I'm not going to be going through the wetland, and I'm going to continue to pasture this. I'm just now going to move the fence over and run it on the north side of that road. And I say, okay, well, if the road's not going through the wetland, then you don't need a wetland permit because you're still pasturing. Therefore, that wetland is exempt. And if it's exempt, it does not have a 50-foot buffer. You see how all these nuances start to come in? They can be completely crazily confusing. So if you have a question, you should just be asking your staff like Rory and others, or reaching out to me, making sure you understand. You can also put in new access roads. Now, new access roads are dependent on what those access roads are for. If those access roads are for agricultural use to go from like one field to another, then we have it's called a water quality registration. And you need to just make sure that your project will meet the criteria and qualify for it. And if so, that's it. You don't need to do anything more. There's no fees. It's basically approved through this registration process. But if you were going to put this same road in, because now you're going to be putting in a subdivision, well, that access road is not being used for agriculture, and therefore it does not qualify for an agricultural exemption. It is a driveway. It is an access road for a subdivision or for a single family residence, and consequently, you need a wetland permit because it's also no longer growing food or crop. So these are the scenarios that I help people work through to make sure that your project is either doesn't need a permit. If it does need a permit, which one? And is there ways that we could make your project happen and avoid the need for a permit, like locating the pond outside of the wetland? And so when I say the pond and the access road are no longer growing food or crop, that is true, and that is the question you should be asking yourself. If you are proposing a new project, within this wetland, I need a new building, I need a new barn, a calf barn, I need a new manure storage, I need to put in a new road for this, I need to put in a pond for whatever reason, I want to put in some new ditches. Those features are no longer growing food or crop. Therefore, the exemption no longer applies. So here are some examples. If you are planning on doing conversion or forestry, first of all, they are not one and the same. Conversion is turning a forest into a field. That requires a permit if it's a wetland. If that same wetland forest and you want to practice silviculture, forestry, and you can follow the acceptable management practices, then that's an allowed use. If you want to do restoration on your land, perhaps along that stream you want to enter into CREP, you want to do a wetland restoration, you want to do a stream bank enhancement so that you don't continue to have erosional issues. Well, that is restoration. You would be submitting a plan to me for review, and I approve it as an allowed use. If you're doing water quality projects, which I know a lot of you are, things like putting in an animal trail or an access road that can meet the water quality project criteria for our registration, then you do have a registration, but there are no fees. There's no notification to landowners. There's no public comment. You basically, you submit the registration and the permit is issued typically within 24 to 48 hours. So when do you need a permit? If you're thinking about big projects, you should really be getting in contact with, if you were involved with NRCS and their engineers. I work with George Tucker all the time, for example. Happy to do site visits, happy to provide technical guidance. But these are big and they're complex projects. And if something happens where you get it wrong, it can just end up being a really challenging to make it right again. If you're looking at new infrastructure in barns, again, it's typically a large project and it covers a lot of area. If you're going to have any type of change in use, if you are no longer going to be growing food or crop, you're going to enter into a contractual agreement for a solar field. If you're going to start subdividing your land to support other types of projects, whether it's housing or something completely different, that now is those new projects are going to end up needing permits if wetlands are present. And then other things that have come up certainly here in Addison County, water lines, transmission lines, gas lines. If you're going to be doing any type of leased areas for roads or for stormwater, as towns are making agreements with landowners to get additional area along their roads to widen roads or incorporate stormwater. Those areas are no longer growing food or crop and a permit might be needed. That may no longer be your responsibility, but those areas now potentially become jurisdictional. So to give visual examples, silviculture. So to the far left, here is the plot of forest that had never been cut down when these fields were established. First of all, that's a red flag, because everybody who's farming typically wants to maximize the amount of land they can farm. So if an area has been avoided for any period of time, there's usually a really good reason why. A, there's bedrock, or B, there's too much water. Those are the two big ones. So, but this farmer would like to, they thought that there's opportunity to expand their fields. So they talked with us, talked with NRCS, and what you see in the middle is the wetland, the forested wetland, and its 50-foot buffer. And then the rest of it was removed and field was put in. That is conversion. If you wanted to practice silviculture, then you could have cut down all of this, but then the wetland and the 50-foot buffer would have had to leave the stumps, do not stump and grub, and it would have to grow back into a forested state. So big differences. If you have any questions at all, do not stump and grub until you get an answer. It can be a very costly mistake. Travel lanes are another one. Often our equipment and our tractors can just, run over the land. Slowly over time, we get the establishment of where you've been driving. As time goes on or as ground gets wetter, then you may say, oh, I need to put down fill and reinforce my access. Or my tractors have gotten bigger. We know that equipment has gotten bigger over time. Now I need to widen this access, and now I need to be cutting back this woody vegetation, which happens to be in a wetland. Some of these activities may require a wetland permit. Others may qualify for that water quality project. So again, if you ask me the question, hey, Zap, do I need a permit, to upgrade this access road? My answer to you is going to be, well, it depends. What is it that you actually need to do? Where are the impacts going to occur? Is it natural wetland? Is it potentially a water quality thing? And I can help you. We can work together to figure out what the next steps are. So I've mentioned water quality projects a few times, and I know a lot of you have been implementing them on your farms. And so these are the water quality improvement projects specifically identified on farms. And when conducted on land, in connection with farming activities, remember my example, if it's an access road to go from field to field, to run your tractor, to harvest your hay, versus I want an access road to be a driveway for a single family residence, project purpose matters. But we're looking at stream crossings and trails and walkways, those access roads, the reinforcement and enhancement of your heavy use protection areas, or incorporating constructed wetlands on your property, which can also be used for stormwater. And then others, which include stream crossing structures or expansion of existing structures. They all have to follow these NRCS best management practices, which are listed here. And these are just some visual examples. So you can get those best management practices by going to the Field Office Technical Guides of Vermont and through NRCS. And if you go down under section 4, practice standards and supporting documents, and you can click down, all of the practices are listed in alphabetical order. So this one I highlighted, it's access road number 560. And this would be how it could be implemented as a clean water quality project. And this would be your rivers and stream crossings. If you're going to be working in perennial streams, you should also be working with your stream alteration engineer and Army Corps. You may need approvals and permits from them. Otherwise, if you're working with intermittent streams, then we have a DEC sizing guidance document that can help inform the best size for your particular location.
How many slides?
8. This would be an example of the travel way where it just gets super muddy and it really is an issue for water quality. And so again, there's specific thresholds, but if your project qualifies under these thresholds, then it's just one of those water quality projects. And here's a visual of what that could look like in 2 different settings, so that we are not having all of that guck and goo going into our waterways. This is your example of that heavy use area. Sometimes just changing or the way in which you manage the area can make a big difference, but otherwise you might be able to incorporate ways in which to prevent muck and mud developing and then discharging. This one is creating wetland, a gravel wetland to intercept tile drainage. Again, tile drainage is its own little beast, and I could do another hour presentation just on tile drains. So if you have questions about getting ready to install tile drains, contact me, and we can look at the areas in question and we can talk about where those outfalls need to go. And so lastly, if this is your typical farm, these white tubes, well, so we have the heavy use area, and that could be reinforced by putting down, stone and gravel and such to stabilize. You could do restoration along the stream. That's where all the white tubes are. Here you could do an animal trail stream crossing so that mud and discharge isn't happening as the animals are going from point A to point B. And if your project doesn't qualify for a water quality project, then they may still qualify for a capped fee total. So if you are wanting to do cropland conversion, if you are going to be doing waste storage facilities, if you're going to be making more permanent structures for farming, assuming that the impact cannot be minimized or avoided, then there are capped fees. I say that with an asterisk, but you do need to also be reviewed under the same permitting standards. So you do need to get a delineation. You still need to have a valid project purpose. It cannot be located anywhere else. You have to demonstrate that there's no impact to functions and values. It is subject to that public comment period. And if you are 5,000 square feet of direct fill, which comes into play for cropland conversion, both for the state and for Army Corps, then your area is subject to the in lieu fee, which right now is approximately $4.62 in the Champlain Valley per square foot. So we're here to help you get your project in place and be at the least costly that it can be. And sometimes that's about moving some of the puzzle pieces around. Last two slides. There is funding available for retiring marginal farmland. We're getting that as a question a lot. You can get involved with the Wetland Reserve Easement through NRCS. You can get enrolled in the current use, which lowers taxes and now can also remove sensitive areas as part of that management requirement so that you don't actually have to do activities in those areas anymore. There's water quality funding available, the clean water providers that can incorporate different practices without cost to you. And then the Conservation Reserve Easement Program, or CREP. Sometimes we can also do permanent conservation easements or land acquisitions, river corridor easements. Fish and Wildlife has been acquiring lands, especially around like Otter Creek and Dead Creek, for example. So if you have any questions at all, contact us. I'll be happy to do a site visit, desktop review, or even a pre-application review. The end.